Good morning, students. In this module, today we will learn about the effects of earthquake, as well as we will also learn about the distribution of earthquake or the earthquake zones of the earth. So let us start. So the effects of earthquake can be categorized into two: destructive effects as well as the constructive effects. So let us first start with the destructive effects. So if we take up the first one, loss of human and animal life. So definitely when the earth's surface shakes or trembles, then the human beings and the animals, they are trapped in the houses where they are living, staying, or they are trapped in the offices. Maybe they are moving on the road and there is an overbridge which breaks due to the earthquake and fall over them. So because of the destruction of the man-made structures, there is also loss of life of human as well as of animals. So this is said to be like a disaster. Disaster means when the built-up structure, man-made structures are destroyed, and because of the destruction, human beings and animals, they lose their life. So like this, these are the first two destructive effects of earthquake. Now the third one is devastating fire. So how fire occurs during earthquake? Earthquake is not related to any, it's not a fiery origin, but when earthquake occurs, especially in the urban areas, like the oil, the gas refinery, the gas pipelines, or the cylinders in the houses, due to the breaking of the houses, the cylinders, they often blast, and this leads to fire. Then if there is a leakage due to earthquake in the gas pipelines, then the natural gas is inflammable. So it's highly inflammable, and so this also catches fire. So like this, there are several incidents of fire also related to the earthquake. Even if petroleum, it is exposed to fire, then also it catches fire as a result of earthquake. So these are the devastating effects of an earthquake. If we learn more, even in hilly areas and mountainous areas, earthquake leads to falling of huge and big pieces or debris of rocks down slope. So as the debris will go down, it will definitely block the roads or destroy the roads, and if the vehicles are going and the human beings are in them, they can also lose their life. So landslide can also occur as a result of earthquake. Flash flood. Now if earthquake occurs and lot of debris or big pieces of rock fall into a river bed, then suddenly a lot of water will be displaced to the surrounding area, causing flood. So like this, a flash flood can also occur. Flash flood means when suddenly flood occurs within an hour or few hours or in a very short time span, then we call it as flash flood. So this can even occur as a result of earthquake. Tsunamis. We have already discussed about tsunamis in the previous module. Tsunami is actually a Japanese word which means harbor waves. These waves are a result of earthquake. When earthquake occurs on the ocean floor, this gives immense energy to the ocean wave, and the small waves, they become huge and gigantic, and they cause a lot of destruction in the coastal areas. Now the next in the list is deformation of the ground surface. As a result of earthquake, the lands get cracked, there is faulting, and even agricultural areas can be destroyed because of the cracking of the surface. So like this, deformation, the ground surface may get deformed, and there can be loss of agricultural land. There can be other destructions too because of the earthquake. So students, these are the destructive effects of earthquake. Now we will proceed towards the constructive effects of an earthquake. So the first in the list is formation of geysers and hot springs. So what are they? geysers and hot springs are associated with volcanic activities. Underground water, when they come in contact with volcanic lava or magma, then they acquire temperature, and the temperature of the water increases. So due to a sudden movement in the earth crust, when cracks appear, this water can come out to the surface of the earth in the form of hot spring or geyser. This hot water or the steam which comes out from the cracks as a result of earthquake, the steam, the superheated rather, the steam has a very high temperature. This energy of the steam can be converted into is a geothermal energy. It can be converted into geothermal energy we get from the earth. So this energy of the steam can be converted into electricity. So this is how the geysers and hot springs can be beneficial. Even though hot water has some medicinal properties because they have valuable mineral. Students, you must have heard of religious places where people go and take hot water bath. So this is a religious bath. So because this water is actually, it comes from geysers and hot springs. And when people go and take bath in that holy water, they consider it to be holy water as their religious sentiments are attached to it. So when they take bath, they are exposed to the minerals in the water of the geysers and hot springs. And these minerals, they have medicinal properties, healing properties. So they are very good actually for us. So when we go and take bath, in the water, holy bath in the water of the geyser and hot spring, then it is beneficial to us. Now, even earthquake result in formation of bays and gulfs. Now, bays and gulfs are indentations in the coastal areas. Now, how they are formed? When the land mass is eroded by the action of the sea water, then gulfs or bays are formed. But you know, due to earthquake also, sometimes the coastal area go inside the water, is drowned, is submerged inside the water due to earth movement in the earth crust as a result of earthquake. So as a result of earthquake, when part of the coastal area is submerged underwater, it may lead to the formation of bays and gulfs. So this is how the constructive effects are also there of an earthquake. Apart from this too, earthquake waves. When we learn about earthquakes, we learn about the behavior of the earthquake waves. So they give us a lot of information about the internal structure of the earth. Now students, it's very interesting that when we study about the nature of or movement of the earthquake waves, P, S and L waves, then we also come to know about how our earth is inside. How the earth is actually inside, we have never seen, because we have not been able to go more than 6 kilometers deeper into the earth crust. Beyond that, we have never went beyond 6 kilometers. So, the earthquake waves, their behavior tells a lot about the change in density, change in pressure condition and all about the interior of the earth. So these are the constructive and destructive effects of an earthquake. Now students, the next topic we will learn about the distribution of earthquake or the earthquake belts or zones on the earth. Our next topic is causes of earthquake. So there are different causes. So the most basic is that the earthquake waves generate from the focus and they lead to the shaking of the earth crust. But why these waves start or originate from the focus? So the reasons are listed here. Volcanic activities. So definitely students, when a volcano erupts, the gases inside the crust, below the crust, it exerts pressure due to which there is crack in the crustal part of the earth, and then a fissure or a crack is formed, and from where the lava comes out. So due to a violent volcanic eruption, it is often followed, rather eruption as well as earthquake, they go side by side. So whenever there is a volcanic eruption, there is an earthquake, because both are related to the movement of the earth crust. So whenever there is movement in the crust, that is a phenomena which is known as an earthquake. Now there is an example. In the last module we had discussed about Mount Krakatoa, which was a volcanic peak, and it is actually in between two islands of Indonesia. These two islands are of island of Sumatra and another one is island of Java. So between Sumatra and Java, Mount Krakatoa, it erupted so violently that even it was the tremors of the earthquake. Earthquake was also followed by it, and the tremors of the earthquake was even felt near Cape Horn. So it was felt to such a long distance. This shows that how violent the eruption was, and even it triggered the earthquake, and the earthquake's magnitude was very high. And you know, 30,000 people were killed in Sumatra and Java and the surrounding islands because of the earthquake, and which induced a huge gigantic tsunami wave. So the tsunami was induced due to the earthquake, and because of which 30,000 people died around that region of the volcanic eruption and of the earthquake. Now, the next cause of earthquake is folding and faulting. Now, students, we have learned in the previous modules about the force of compression. That is, when the forces move towards each other and a land mass is folded. So, that is force of compression. In case of this, force of tension, when the crust get cracked and it moves apart, move away from each other. So there the reason is force of tension. So force of compression and tension, both the forces, they lead to the movement in the crustal part. It can be towards or it can be away from each other. So like this, the force of compression as well as tension, which is responsible for folding and faulting, leads to earthquake, means movement in the crustal part of the earth. Let's proceed to the third factor, anthropogenic causes and hydrostatic pressure. So anthropogenic causes are human-induced causes. Like human beings, we dig underground wells to take out petroleum, or we make huge and large reservoirs to store water for the dry season. We even do mining, quarrying. So when such activities are done, then unintentionally, we don't do it intentionally, unintentionally, crustal imbalance occurs. And due to the imbalance in the crustal part of the earth, often earthquakes occur. So this is how human beings are also at times responsible for occurrence of an earthquake. Hydrostatic pressure here means by the excessive pressure of the water. So one example I would like to give you. In the Koyna district, a Koyna dam is there on Koyna river in the Satara district of Maharashtra. So here, lot of water was stored behind the Koyna dam in a big reservoir. A big reservoir was constructed and in which lot of water was stored. You know what? The pressure of the water was so much that it led to crustal imbalance, and this resulted into an earthquake. So this is how even human beings can lead to earthquake. Now apart from these three causes, there is one more and very important, that is plate tectonics. Now students, we have discussed a lot of things about plate tectonics when we were learning the module rocks, when we were learning about folding and faulting. So here we will just briefly discuss and we understand how it is related to occurrence of an earthquake. we have learned that the ocean and the continents, they are divided into different plates. So, and these plates are lithospheric plates because they are made up of rocks, and these plates, they keep on moving. Either they move towards each other or they move away from each other, and in the third case, they just move parallel, they slide past. Neither they collide nor they move away, rather they just move parallel without causing any destruction. So like this, plate tectonics, when the plates move, either they converge or they diverge, they lead to the movement of the crustal part of the earth, and this is how an earthquake occurs. If we can discuss a little more, when two plates converge, then I have told you students that when two plates converge, one plate will go below in the subduction zone and another one will override. So the part of the plate which goes below, part of it gets melted, because we know as we go deeper the temperature is more, so the solid rock will melt and will remain in molten state. So like this, the earthquake and volcanic eruption both can occur because of the plate tectonics, and definitely they occur. Mostly both of them occur together. Now if we take another example, the Pacific Ring of Fire. It's a very good example of the plate margins. Here we were talking about the plate tectonics. So in plate tectonics, the plate margins are mostly along the Pacific Ocean. So we have studied that all along the Pacific Ocean there is a belt of volcanic eruption. Active volcanoes keep erupting frequently. You know students, this is also a belt of active earthquake. Means earthquake also occurs along this belt because of the movement of the crustal part of the earth. Now this is how the plate tectonics also lead to earthquake. If we take an example from India, so the earthquake of Bhuj, all of us remember because it was a very recent earthquake in India, in which there was a lot of destruction and there was a huge loss of life and property. People suffered a lot, and it took the government very long time for the rehabilitation and the reconstruction work. It took the government a very long time. Now, why this earthquake took place? This earthquake took place because of the converging plate boundaries. The Asiatic and the Indian plate, they converged, and the Indian plate, it went into the subduction zone, and the Asiatic plate, it overrided the Indian plate. So because of that, the earthquake of Bhuj occurred, because Bhuj is at the plate margin and plate boundary, and when two plates will collide further, they will converge, then definitely the part of the earth crust will move and it will lead to earthquake. So students, often we hear about earthquake, but mostly they are related to the mountainous and hilly areas. Because the mountainous areas, especially the Himalayas, which is the zone of fold mountain. So here the folding is continued, the process is there, it's ongoing process. Every year the height of the Himalayas are increasing. So as they are getting folded, the crust is moving, and because of the movement of the crust, earthquake occurs. So these are the reasons or the causes behind an earthquake. The next topic is the distribution of earthquakes. So the main earthquake belts are the Circum-Pacific Belt, the Mid-World Mountain Belt, and the Mid-Atlantic Ridge. So these are the three earthquake belts spreading all over the earth. So let us see the map and we'll look at each and every belt one by one. So we'll start with the Circum-Pacific Belt. So all along the Pacific Ocean, that is along the coast of North America, South America, and also this side along the coast of Asia, Indonesia, it stretches all over this area, is known as the Circum-Pacific Belt. So we can say that there are many fold mountains present in this belt along the margins of Pacific Ocean. Like if we see South America along the Pacific Ocean, there is Andes mountain range. In North America, the Western Cordilleras, the Rocky mountain range is there. Now, if we move to Asia towards near Japan and even extended up to Indonesia, these are the areas of plate boundaries or plate margins. So here plates collide and therefore due to this being the area of plate boundaries, they keep moving. There is a lot of movement experienced here and this result into earthquake. So this is a region of crustal disturbances. So largest number of earthquake occur in this area. The area means area surrounding the Pacific Ocean. That is 70% of the total earthquake experienced is in this belt. This zone represents the junction of continental and oceanic plate margins. So students, we have learned that Pacific Ocean is or Pacific plate is the largest single plate which is only oceanic. There is no landmass in it. So this plate and the continental plates, this is actually a junction where the oceanic plate and the continental plate, they merge. You can see here this side of the Pacific Ocean also, this is the eastern part of Asia which is along the Pacific Ocean, and this is the western coast of North America and South America along the Pacific Ocean. So this belt forms the largest earthquake belt in the world. Now the next in the list is the Mid-World Mountain Belt. So students, I told you earlier that volcanic activities and earthquake, they go side by side, because when volcano erupts, definitely there is shaking of the earth crust and there is an earthquake. So the Mid-World Volcanic Belt or the Mid-World Earthquake Mountain Belt stretches from Europe to Asia. Stretches from Europe to Asia all along this area, and along the alpine Himalayan belt where the young fold mountains. So the Himalayan belt is the area of young fold mountain and is very much prone to this hazard. This belt accounts for 20% of the total earthquake of the world. So if we consider this area, 20% of the total earthquake occurs in this area and 70% in the Pacific belt of earthquake. So these are the two major belts. There is one more belt apart from this, that is the Mid-Atlantic Ridge. So you can see from the center of the Atlantic Ocean, you will find out a S-shaped steep sided ridge, series of we can say steep slope sided mountains which is on the ocean floor of the Atlantic Ocean, and we can see the upper part of the ridges out of the water or above the ocean water. So this is known as Mid-Atlantic Ridge. So let us learn more about it. This belt includes the region of Mid-Atlantic Ridge. So this is the region of Mid-Atlantic Ridge from where two tectonic plates get apart. So from this area, two tectonic plates actually they moved away from each other. These plates moved in opposite direction, spreading the sea floor. So some of the moderate earthquake occur along this ridge. So this whole area, the whole region was earlier connected, but because of the diverging plate boundaries, they moved away from each other. You can see the arrows pointing away from each other. So this led to the opening of a sea, means there was a rupture crack in the crust because of the divergence of the plates, and the magma, molten magma, came out on the earth crust. So 10% of the total earthquakes of the world are associated with the submarine ridges. Ridges means the steep sided mountains that have formed on the ocean floor. These are called submarine ridges, rift valleys and other areas. So as on the earth's surface there are mountains and valleys, on the ocean floor also there are mountains and valleys. So The first belt, that was Pacific, circum-Pacific belt, it contained 70% of the earthquake prone areas, and followed by the mid mountain belt, which contains 20% of the total earthquake prone areas, and this mid Atlantic ridge, it contains 10% of the total earthquakes of the world. So this is the distribution of earthquake zone in the world. Now let's see the condition in India. You can see in the map with different colors it's highlighted. With the blue color it's zone 1. So this is the zone which is less prone to earthquake. Then more than this is zone 2, which is shown with a lighter yellow color. This is not so much prone to earthquake. Then comes zone 3, that is little darker. So here the intensity of earthquake, or the chances, probability of occurrence of earthquake is much more compared to zone 2. Then move to zone 4, which is shown with a red color. So this is a high intensity zone, means these areas are highly prone to earthquake. Now students, you can see here this part of Gujarat, and if we recall, this is the place, this portion or this region, here only is located Bhuj, and nobody can forget the earthquake of Bhuj, which was very destructive. Let us see in the map. So here is Bhuj located in Gujarat, and the destruction caused during the earthquake of Bhuj was tremendous. So let us come back to the map of India and let us discuss more. In India, the Himalayan region is most prone to earthquake. The fold mountains of like the Great Himalayas are still rising. So these are fold mountains. So folding is still going on, is a continuous process. So they are still rising, and because the movement is so slow, and as a result the Indian plate is moving towards the Asian plate. So what is happening along the foothills, means along the lower slopes of the Himalayas in the Indo-Gangetic plain, also some of the severe earthquake occurs. So in the Indo-Gangetic plate also severe earthquake occur because of the movement of the Indian plate towards the Asiatic plate. They are more devastating because foothills have high density of population. Now students, the earthquake is devastating, we can say in that sense, more damage it causes. So if the plain areas of Ganga has high population density, then the destruction will also be more. If any area is experiencing earthquake very severe of high intensity, but the population is very less, so destruction will also be less. So in this respect, if earthquake occurs in the foothills, in the plain areas, then it is very devastating. Deccan Plateau is comparatively a stable landmass, so the earthquake with low intensity occur in this region, but some of the severe earthquakes were experienced in Koyna. So in Maharashtra, in the Satara district, in Koyna river, there was a severe earthquake caused due to hydrostatic pressure. We have discussed about this earlier. Then there were other earthquakes also, and a very recent example is of the Bhuj earthquake. So let us see the picture, the map, and let us learn more about Bhuj earthquake. So it took place in 2001. It gave indications of seismic instability of this plateau. A severe earthquake shook the Kutch region of Gujarat. So this is the Gulf of Kutch. So this region was hit by an earthquake, and its intensity was 8.1 on the Richter scale. So students, we have learned if it is more than 5 in the Richter scale, it is a destructive earthquake, and so the intensity of here was 8.1. So it was very destructive, and the time is 8:45 AM on 26th January, and the year we have already mentioned, 2001. So Bhuj, Ahmedabad and Rajkot were adversely affected by this earthquake, which resulted in a large scale destruction of life and property. The epicenter was situated near Bhuj. So somewhere near Bhuj the epicenter was there, and students, we have discussed that at the epicenter the intensity is felt maximum destruction happens, and then as we go far from the epicenter the destruction becomes less. So this is all about the distribution of earthquake all over the world in India, and also we took the case of Bhuj earthquake and we learned something about this. So that's all in this module, students.